Hey guys, it's Mr. C, and in this video we're going to talk about some integer exponents. So the first thing I'm going to show you, we have a little graphic organizer with a bunch of properties on it. First one's the product of powers. When you have two bases that are side by side and you multiply them, you add the exponents. Quotient of powers, when the two bases are being divided and it's the same base, you can subtract the exponents. I'll use that sometimes, and then sometimes I'm going to do something different. Power of a power. You have a power, an exponent raised to another exponent. When that happens, you multiply them together. Power of a product. What that means is you can basically take an exponent, and if you have more than one item, one factor in here being multiplied, you can distribute the exponent to both of those. Power of a quotient, same idea, but it's with division. You can distribute that exponent to whatever's inside the parentheses in the fraction. Zero exponent, anything to the 0 power is equal to 1. And you have negative exponent, a to the negative 1 is equal to 1 over a, and this is going to be like a flipper. And so I'll be using that terminology to explain negative exponents because they behave like flippers. So I'm going to keep that little graphic organizer handy over here, and as we work through these, I'll be referring back to it if I need to, so I can kind of see it right over there. All right, so we've got a whole bunch of examples here. First one's 2 to the 5th power. 2 is your base, 5 is your exponent, and we call the whole thing a power, but I'm going to refer to this as 2 to the 5th power because pretty much everybody does. It says simplify. So basically 2 to the 5th power means 5 2's multiplied together. And so you can write them all out if you want to. So if you multiply all 5 of those 2's together, you're eventually going to get 32. And so when you evaluate this or simplify it, if it's just a number, you're just looking to see the single number that equals. Instead of 2 to the 5th, it's 32. Our next one is 3 to the 4th. And so again, you have 3 to the 4th power. That's 4 3's multiplied together. 3 times 3 times 3 times 3. And so if you think about it, these two 3's make 9. These two 3's make 9. And 9 times 9 is 81. So 3 to the 4th power is equal to 81. So I know you learned that a long time ago, so let's talk about some negative exponents. So this negative exponent does not make anything in here negative necessarily. What it does is this negative exponent acts like a flipper. And what it's going to do is going to take this 2, this base, and it's going to make the reciprocal of that. So you're going to flip that 2. So if we have 2 over 1 as our base, if you flip this, you get 1 over 2. That's called the reciprocal. And so what it's going to do, it's going to make the reciprocal 1/2, and then you make the exponent positive after you apply that. And that's what negative exponents do. They're flippers. Now, there's a couple ways we could do this. I'm going to choose this way, 1/2 times 1/2 times another 1/2, because that's actually what's happening here. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. And so 2 to the negative 3 exponent, negative 3 power, is equal to 1/8. Here we have 7 to the 0 power. And as we just looked at, anything to the 0 power is equal to 1. And so we would say simply 1, and then that is it. And I'm not proving that, although the proof of that isn't very difficult. They might prove that at some point in a different part of the course or later on in the lesson if I need to come back to that. 3/4 cubed is really just 3/4 times 3/4 times 3/4. And so if we multiply 3/4 times itself 3 times, we get 3 times 3 times 3, which is 27. 4 times 4 times 4 is 64. And so 27 over 64 would be our final answer for that one. However, there's another way you could do this, and that is using your power of a quotient property right here that says that that exponent can distribute to each of these guys in the parentheses in the fraction. So what's going to happen is this 3 will distribute and become an exponent for both those guys. All right, so what does that look like when we're done? 3 to the 3rd power over 4 to the 3rd power. And as we just saw, 3 cubed is 27, 4 cubed is 64, and you still get the same answer that you did before, so that's good. Okay, this one we have 1/3 to the -2, so we need to flip that. And so the reciprocal of 3/1/3 is 3/1. And then we change that to a +2. Well, 3/1 is just really 3, isn't it? And then 3 squared is 9. And so that one is done. In this one, we have -5 to the -5 power. And so we need to take this -5 and flip it into -1/5 to the +5. Okay, so now I'm going to do something different. I'm going to talk about first, is this answer going to be positive or negative? Well, you have 5 negatives that you're about to multiply times each other. So if you take 5 negatives, 1, 2, 3, 4, 5, we know that they cancel in pairs. 2 negatives make a positive, 2 negatives make a positive. And since that's odd, you're always going to have one left over. So I know my answer is going to be negative. Now I'm going to go ahead and I'm going to use my property that says I can distribute that 5 to both of those. And that's, again, called my power of a quotient property. So I'm going to get 1 to the 5th over 5 to the 5th. Okay, so it's still negative. And the negative exponent didn't make it negative. The fact that that's an odd number made it negative. All right, so now we have negative. 1 to the 5th is 1. And 5 to the 5th is 31/25. And now -1/31/25 is my final answer. All right, here I have something interesting. I have a 4 to the 1st power over 4 to the -3. So what's going to happen here is this 4 to the -3 is going to move. And this is going to move up to the numerator. And that 3 is going to become a positive exponent. When this moves, here's what it looks like. The 4 to the 1st power is still there, times the 4 to the 3rd power that just arrived up there and now is positive. So what's left in the denominator? A 1, because everything moved. So now let's take a look. I have 4 and 4, same base. So I'm going to add the exponents together because that's what my product of powers property says. So I'm going to add the exponents, and 1 plus 3 is 4. Now I'm going to drop the 1 because I don't need the 1 in the denominator. So I'm not even going to write it. So now I just have to figure out what 4 to the 4th power is, and that is going to be 256. All right, in this example, I have 2 negatives now. And since I have 2 negatives now, I'm going to have some stuff move. So what's going to happen here is this guy, a to the -1, is going to move up into the numerator. And at the very same time, this 32 to the -1 right there is going to move down to the denominator. And what's going to happen is they're going to switch places. So when they switch places, the a to the 1st power is now up top, and the 32 to the 1st power is down below. So they're both to the 1st power, so I don't really need that 1 there. So I have 8 over 32. And now I have a fraction, and can I simplify that? I think I can divide them both by 8. And you always want to simplify your fractions if you can. 8 divided by 8 is 1. And 32 divided by 8 is 4. And so our original expression turns out to be just positive 1/4. Here I have 3x squared, and now I have our power of a product property that says I can take this exponent and distribute it to everything in the parentheses as long as there's no plus or minus in between them, and there's not. It's multiplication, right? So I can distribute this 2 to both of the exponents in here. Well, both of the exponents are 1s. So now 2 times 1 is 2. So I'm going to get 3 squared times this exponent here is a 1. 2 times 1 is 2, x squared. The only thing I can do with this now is just actually take the 3 squared and turn it into 9. And so 9x squared would be my final answer for that one. Okay, this one, I'll do a little differently. I have everything multiplied together. And so actually I can take each item in here and put them in their own set of parentheses, and it will not affect anything in here because it's all being multiplied. So I'm going to do that. 2x cubed, -5, and x. It's going to be more instructive if I do it this way. So now I'm gonna look at it, and I'm gonna always deal with the numbers first, namely the 2 and the -5. So I need to multiply those together because everything's being multiplied. So 2 times -5 is -10. Okay, so now let's talk about the x's. So I have an x cubed and another single x to the first power. Again, they're side by side, so you add the exponents, and 3 plus 1 makes 4. So I have x to the 4th power, and then this would be my final answer for that one, -10x to the 4th. All right, here I have one, and sometimes there's more than one way to solve these to simplify them, so I'm just gonna do each time. I can't do every single one or the video is gonna be a couple hours long. So what I'm gonna do is I'm gonna do it the way I would do it, okay? Not necessarily the way a textbook would do it, but the way I would do it. So I'm looking at this right here, and the first thing I notice is I notice this 2 on the outside, but then I also notice in here I have a couple b's. I have 4 b's up here and 7 down here. So 4 of these b's are going to cancel with 4 of these, and when they do, it's going to leave 3 of them still left down here. And so what I'm going to get is a over b to the 3rd power. So when 4 of these cancel with the 7, it's still going to leave 3. Now, all of this is still squared. So now I'm going to apply my power of a quotient property, and I'm going to distribute that 2 to both of those guys. So now a to the 1st power squared is a squared. B cubed to the 2nd power, 3 times 2 is 6. So a lot of students, what they'll do here is they'll confuse this property with the product of powers. So when they're a power of a power, you multiply, and when they're side by side, you add. These are not side by side. This is a power of a power. So a squared over b to the 6th has to be my final answer. So let me go back really quick and show you what happened up here. I'm going to ignore the 2 right there. I'm going to write a, and I'm going to write 4 b's like that. Then I'm going to put 7 b's in the denominator here just to show you what happened. 1, 2, 3, 4, 5, 6, 7. We know that these b's are going to cancel in pairs. Anything cancels in pairs because they're multiplicative inverses. So when they cancel like this, we see clearly that the a is still left on top, and then there's 3 b's, b cubed, left in the denominator. So it's easier to do it this way because you don't want to have to write all these out when these numbers start to get really big, when the exponents get really big. So you want to really learn the rules because they're a lot easier to apply, especially when you have large exponents. All right, now we have 5x to the 6th cubed. So I'm going to apply my power of a product and distribute. Okay, so I'm not going to multiply 5 times 3. I'm going to make it 5 cubed times x to the 6 times 3 is 18. You don't add, you multiply. What's power of a power? This is good, but I can still say that 5 cubed is 125. Still x to the 18th. And then that's done. There's nothing more you can do with that. All right, this one, I've got -2a cubed, and then I've got b to the -3. All right, so what I'm going to do is I'm going to distribute this -3 to everything first and then see how this kind of shakes out. If I distribute this to everything first, I'm going to get -2 to the -3, a to the -9, b to the -3. Okay, so what's going to happen now is everything has a negative exponent, and I can put all of that under 1 because when you make this reciprocal, all of this has a negative exponent, so nothing's going to be left in the numerator. So in the denominator, I now have -2 to the +3. See, it didn't do anything to the negative, did it? Times a to the +9 times b to the +3. Okay, so I can't do anything with the a and the b, but I can definitely take -2 cubed and make that into -8. So now I have 1 over -8, a to the 9th, b cubed. I could take that negative and put it out front. I could put it up top with the 1, or I could just leave it down there. Any one is fine, not a problem. Okay, this example, I'm squaring everything. So again, I'm going to distribute this 2 to everything. Negative 3 squared is going to be a positive 9. A squared squared is a to the 4th. B cubed squared is b to the 3 times 2 is 6. So notice that I didn't write it all out again over here, did I? Eventually you're going to get to the point where you can distribute, and then you can do them directly like I did after you distribute. Just make sure that this negative goes along with this 3 when you square it, and it did become a positive 9. And that's my final answer for that one. Okay, so let's talk about this one here. This one, I'm going to go ahead and write the fraction here because I don't know quite what's going to happen. This 5 really just has no number down here to work with. There is a 1, but 5 divided by 1 is still 5. So that 5 is still going to stay up there. All right, that's x to the first power. I've got 1 up here and 2 down here. This one is going to cancel with one of these and still leave an x in the denominator. 6y's here, 2 here. So these 2 are going to cancel with 2 of these and leave 4y's in the numerator. So we see wherever the majority is, that's where the final answer is going to wind up for that variable. There are more x's here than here, so the x wind up down there. There's more y's up here than there are down here, so that's where the y's ended up at the end. And then there's nothing you can do with that. That is done. Okay, this one, I'm going to distribute this 2 to both of these. The variables are different, so I can't do anything with those. I can't combine them. So 5 times 2 is 10, so y to the 10th over 2 times 2 is 4, x to the 4th, and then there's nothing you can do with that. That one is done. Okay, in this one, everything's being multiplied, but I need to do this first, and even the order of operations say I need to do this first. So the negative 4m has to kind of hang out here. So I'm going to say negative 4m times, okay, let's distribute, m to the first power cubed is m cubed, and n squared cubed would be n to the 3 times 2 is 6. Now I'm looking here, the only things I see that I can combine is this m to the first power and that m to the third power. And so if the bases are side by side, you add them together, the exponents, 3 and 1 make 4. So my final answer would be negative 4 m to the 4th n to the 6th. And that's all you can do with that. All right, so now we've got this popular one. This is a good ACT question. You're going to be very tempted to cancel stuff out, but you can't cancel things out until you deal with that exponent. So we're going to deal with that right now. We're going to distribute that. The 2b is still going to be down here, but 4 squared is 16, b squared. Okay, so now we can go ahead and start canceling. 16 divided by 2 is 8. B squared over b, that 1 is going to cancel with one of those and still leave 1 up there. And everything canceled in the denominator, and it leaves a 1. So my final answer would just be 8b. Okay, this one, I got a bunch of negative exponents. So let's talk our way through this one. All right, so what's going to happen, and I'm going to explain this. You've got 3 x's down here already. This negative 1 is about to come down here and combine with that 3 and be a positive 1. And when it does, it's going to be 3 plus another 1 would actually make 4. So I'm going to get x to the 4th down there. These 5 y's are going to move up top, and these 2 are going to be down below. Now, I don't want to do that all in one step, so I'm going to show that happening here. These 5 y's are going to go up here, and these 2 y's are going to go down in the denominator. Now let's deal with the y's again. 5 up here, 2 down here. These 2 are going to cancel with 2 of these, and there's still going to be 3 left. Got rid of all these y's here. Those are gone because they canceled with 2 of these up here. I still have x to the 4th, and then that would be my final answer for this one. All right, so here we have a fraction, and there's a lot of stuff going on. Let's do it this way. Let's first deal with this 68 divided by 4 issue. So if we have 68 divided by 4, I believe that's going to be 17. And so here's my fraction. 68 divided by 4. 4 goes into 4 one time, goes into 68 17 times. So 17 is going to remain there. These 3 F's are going to flip up here and go with these 5 that are already there. And it's going to add. So 5 and another 3 that's coming up there are going to make 8. I have 6 G's down here, and these 3 are about to flip down with that 6, and it's going to make 9 in the denominator. And there's really nothing else you can do with that. That's pretty much done. All right, this one, we saw one like this earlier, but I'm going to do this one just a little bit different. I'm going to deal with this negative exponent first. I'm going to write 1 over all of this to the positive 2. Negative 4 a cubed b to the 7th squared. Okay, so I went ahead and dealt with the negative part. Now I'm going to square everything in here. So equals 1 over, all right, negative 4 squared is 16. A cubed squared, 3 times 2 is 6. B to the 7th squared, 7 times 2 is 14. And there's another way that you can handle this one. When you have a negative exponent out here, you can flip it first and then you can distribute your exponent to everything. And that would be your final answer for that one. All right, so here, this one is kind of interesting. This may take a couple steps. All of this has nothing to do with this. This is going to get flipped. This is not. So I'm going to get 6m to the 4th n to the 9th over all of this stuff squared. Okay, so negative 3 m squared n cubed, and all of that is going to get squared because I have a negative exponent and now it's been flipped down and now it's positive. In my next step, I'm going to go ahead and distribute that 2 to everything. Now my numerator is still the same. It's not going to change because I'm not going to worry about that. 6 m to the 4th n to the 9th. Negative 3 squared is 9, positive. M squared squared is m to the 4th. N cubed squared is n to the 3 times 2 is 6. Now let's simplify. So I'm going to assume this is going to be a fraction when I'm done. 6 and 9. 3 goes into 6 2 times. 3 goes into 9 3 times. So I've dealt with the numbers. The m's have the same exponent, which means both those m to the 4th are going to completely cancel out. All of them are going to cancel out with each other. So the m's aren't even going to be in my final answer. Got 9 m's up here, 6 down here. So these 6 are going to cancel with 6 of these and leave 3 still there. So 2n cubed over 3 is my final answer for that one. Okay, this one, I've got 3 variables, so let's see how this is going to work. Okay, so what I usually do is I deal with each variable individually. All right, so 7x is here, 4 here. So these 4 are going to cancel with 4 of these and leave 3. Y's, I've got 9 here and 7 here. So these 7 are going to cancel with 7 of these and leave 2. I've got 8 z's down here. I've got 3 up here, which means these 3 are going to cancel with 3 of these and leave 5. And then that's it. That's your final answer for that one. All right, this one, I'm going to go ahead and before I apply that 4 there, I'm going to try and clean this up a little bit to see if I can make that look a little bit better. So I'm going to attempt to do it. Let's see how this is going to work. It's probably still going to be a fraction in there. You never know. All right, I'm going to leave that open. Okay, so these p's, negative 3, there's no other p variable in here. So these are going to go flipping down below, and it's going to be a positive 3. So I got that. These 2 q's and these 3 q's are going to swap places. And so I'm going to get q to the 3rd up here, but I'm also going to get q squared down there. R to the 5th, there's no other r in here. Let me check those off. It's positive, so it's going to stay down below just like that. Close it up to the 4th. All right, do I have anything else I can clean up here? So your final answer should have, each variable should appear only once in your final answer, and you shouldn't have any negative exponents. So the only thing I can do is I can clean these q's up. I've got 2 q's here and 3 up here, which means there's still going to be 1 left in the numerator, but everything else is going to be the same. P cubed, r to the 5th, and all of that to the 4th. So once I get everything cleaned up inside the parentheses, I can now distribute this 4 to everything. So that q is to the 1st, so 4 times 1 is 4, so I have q to the 4th, over 4 times 3 is 12, p to the 12th, and then 5 times 4 is 20, r to the 20th. And then that's your final answer for that one. All right, let's see what's gonna happen with this one. So for this one, I've got x's, y's, and z's, so something's gonna happen. All right, I got 4 x's up here. This -1 is gonna come up here, combine with the 4, so 4 plus 1 is 5. Okay, these 8 y's are gonna drop down with that 6 and add to it, and 8 plus 6, 14. So I'm gonna have 14 y's down below, because these are gonna drop down. These 2 z's are gonna switch places. I'm not quite sure if we can handle switching places and simplifying at the same time. So I'm gonna flip them. I'm gonna put z to the 10th up here and z squared down here, and then I'm gonna handle that in my next step. So equals. All right, so my last step, the x's and y's did nothing, but my z's now can be simplified. So these 2 are gonna cancel with 2 of the 10, and it's gonna leave 8. And then that's my final answer. All right, let's take a look at this one. So in this one right here, you have all of this stuff, and there's a lot of stuff, to the 0 power. You could sit there and work through all this and move the n down and then make the 2 cubed an 8, but really it's all to the 0 power. No matter what this is in here, it's gonna equal 1 no matter what. So there's really no work to be done there. That's just your 0 exponent property. Okay, our final example. In this one, we need to simplify a little bit first. So these 2 guys, I'm gonna multiply, and then I'll deal with this. So let's go ahead and write a fraction bar here, because we're gonna need it. Okay, so 4 times 3 is 12. X squared times another x to the 1st power, you add, because they're side by side. 2 plus 1 is 3, so I have x cubed, still over 6x to the 4th. Okay, now I'm going to be able to write my final answer. 12 divided by 6 is 2, and that 2 is going to be up here because the 12 is bigger than the 6 and it's up top. 3 x's in the numerator are going to cancel with 3 of them down here and leave 1 single x down below. And my final answer is 2 divided by x. All right, guys, remember to like my video and subscribe to my channel. And this is Integer Exponents, and we will see you guys later. Bye.